right, this is the second of 3 parts for our Forces 2 unit, and so it's statics. When we really think about statics, we're talking about things like tension and stuff, and most of you guys have hung from like monkey bars before, so if we just hang from one monkey bar, then all of the tension or statics or force is in one arm. And all of the force pulling us down, which would be our weight, would have to be all in that single arm that is going up. Now, if we held ourselves like we were just hanging from the bar with both arms, like we were going to do pull-ups or chin-ups, then our weight would be distributed evenly amongst both arms. So we would take our weight, which would be the downward force, and we'd have to balance it with the up forces, and we have 2 up forces, so we would just take our weight and divide it by 2. All right? So when we're really talking about things like statics, it's like hanging pictures or us hanging. And so all the forces, remember, are in equilibrium. And when something is at equilibrium, it means that the forces acting on the body are balanced and it's not accelerating. So because the object is not accelerating, we know that the sum of the forces in the horizontals, all the right and all the lefts, have to balance out to 0, and all the forces going up and down have to balance out to 0. Okay, another way of writing that would just be the summation signs, which are our epsilon signs, and we could say f of y equals 0 and f of x equals 0, talking about our horizontal and vertical planes. So if I also could talk about things hanging at an angle. So a 50 Newton sine hangs by a single wire as shown. What's the tension in the wire? Well, a couple of things that we can automatically do. We can draw an F of G, which is going to be 50 newtons. And we can think about it as, you know, we can construct the tension, because the tension that we're looking for, and tension really is just a force, so that's the thing to remember as well. So our tension is right here in the strings. So we could label it as F of T or just T, either one. Actually, I probably ought to label it as F of T. It makes more sense right now. All right. So the way to solve these types of problems is to construct one of the triangles. So for this one, let me check something really quick. So when I construct one of the triangles, the thought process is let me look at it like it's a 90-degree angle right here. If this is 40, right, or sorry, I just answered my own question I'm about to ask you. If this is 100 right here, then if we look at it as a 90-degree angle, this is 50, so that would make this 40. So when we construct that triangle, we have a 90-degree angle, a 40-degree angle, and we have a hypotenuse that's labeled F of T right now. Okay? Then the next thing to understand is we have to calculate the part of the weight that it supports. Well, remember that our weight is going straight down. Okay, so we have an F of y going up right here. Well, because we have another triangle over here, we also have an F of y over here. So we have 2 of the forces going up and 1 force going down. So when we calculate the part of the weight that this triangle supports, we would take that 50 newtons and divide it in half because there's 2 going up. So this side would now become 25 newtons and this would become 25 newtons. Just like when I said if we were hanging by our arms, each one would get equal amount of weight. Then we can actually use trig to find the missing side, okay, which is our hypotenuse, F of T. So we have our 25 newtons, we have our 40 degrees, and we're looking for our tension. So we would use sine because 25 newtons is the opposite, and F of T is our hypotenuse. So sine of 40 would equal our opposite over our hypotenuse. So to find the tension, we would have to multiply tension on both sides to get it out of the denominator. And then to get tension by itself, doing our algebra, we'd have to do the opposite of multiplication, which is division, and we take 25 and divide it by sine of 40. So that would give us an answer of 38.9. I think it's like 38.89 if it's not rounded. Let me double check that real quick. So 25 divided by the sine of 40, actually, yes, is 38.89. So that's how we would round it in this class, would be 89 newtons, and that would be our answer for that tension. So that's kind of what you need to be able to do. They won't be any harder than that right there. So the key thing is to construct a triangle, calculate out how many ups you have versus the down weight, and take that weight and divide it by how many you have so that you can find that portion, and then solve accordingly. Use trig to find your missing side. Okay? So like I said, this one's going to be significantly shorter. I'm not going to do the last example. It actually takes quite a few more steps than you really need for your test. So this is kind of the information. If you have any questions, please let me know.